All right, welcome. We're all kind of taught this one story about science, that it's a straight, steady march toward the truth. Well, today, we're going to dig into a pretty radical idea that suggests we might have been thinking about scientific progress all wrong.
Yeah, this is the story you get in school, right? Science is this clean, straight line, always marching forward, getting closer and closer to some final, ultimate truth. But what if that's not it at all? What if the real story is way messier, way more interesting, and honestly, a lot more useful?
So, let's dive in. Our guide for this journey is a really groundbreaking book from 1977 by a philosopher named Larry Loudon. His work, Progress and Its Problems, completely shook up the traditional way of thinking about how science actually works and grows.
Now, you have to understand, Loudon was writing at a time when science was having a bit of a confidence crisis. For the first time in centuries, the whole idea that science was this perfectly rational thing, that was under serious attack. People were finding some major cracks in the foundation.
I mean, this was the bedrock belief, wasn't it? You think of Newton, Darwin, Einstein. You figure they're all just part of this one big project, using pure reason and evidence to paint a clearer and clearer picture of how the universe works. It was supposed to be the one thing we could really count on.
But by the 70s, when Loudon steps onto the scene, that simple, confident story, it was getting absolutely hammered from all sides. You had philosophers, historians, sociologists, all pointing out some really uncomfortable problems, and they were getting pretty hard to just ignore.
So first up, you've got the philosophers. For years, they had built these really neat, clean, logical models of how a rational science ought to work. It was all very tidy on paper. The only problem was, when you actually looked at the history of science, how scientists really behaved, it looked nothing like those neat little models, not even close.
Next up, and this one is a bombshell. For decades, the brightest minds had tried to prove, logically, that the scientific method somehow guarantees our theories are true, or, at least probably true. And as Loudon points out, every single one of those attempts failed. Which of course raises this terrifying question. What if science doesn't have some special secret pipeline to the truth?
Then you've got the sociologists chiming in, and they're pointing out something that seems obvious now, but was radical then. Hey, scientists are just people. They're human. They're driven by things like getting prestige, funding, power, and even politics. And when you look back at history, it was just undeniable that these supposedly non-rational factors played a huge role in deciding which theories won and which ones lost.
And for the final blow, you have historians and philosophers like the famous Thomas Kuhn. They argued that when you have a massive scientific revolution, like the jump from Newton's physics to Einstein's, it's not just a simple upgrade. Yeah, you gain some incredible new ways to explain things, but you also lose some things that the old theory explained perfectly well. So if every big gain also comes with a loss, how can you possibly say that choosing the new theory is a purely rational decision?
So, okay, the whole idea of scientific rationality is on the ropes. The intellectual world is basically scrambling, trying to figure out what to do, and according to Loudon, they basically got stuck between a rock and a hard place, with two really, really bad options. Okay, so option one, you could just keep trying to patch up those old broken models of rationality. Just keep tinkering, hoping that maybe one more little tweak will finally make them work. Or option two, you just give up, throw your hands in the air and say, you know what? Science isn't rational after all. It's just a game of power and persuasion and who has the most influence.
And you can see the dilemma here, right? One option feels like you're just banging your head against a wall forever. And the other one, it feels like a total surrender. It's giving up on the very thing that seems to make science so special and powerful. It really felt like an impossible choice.
Okay, so this is where Loudon comes in with this just brilliant, game-changing move. He basically steps back from the whole mess and says, hey guys, what if the reason we're stuck is because we've been asking the completely wrong question this entire time?
And this is a huge shift in thinking. For, literally centuries, the big question in science was always, is this theory true, with a capital T? Loudon says, let's just set that question aside for a minute. Let's ask a totally different and maybe more powerful question. Does this theory actually solve the problem?
This little pivot opens up a whole new way of thinking, and it gives us this fantastic analogy. Stop thinking about theories as these perfect detailed maps of reality. Instead, start thinking of them as tools. Just tools in a toolbox.
And this just nails the point, doesn't it? You would never ask if a hammer is true. It's a nonsensical question. You ask, does it work? Does it do the job I needed to do? And Loudon's big idea is that we should treat scientific theories the exact same way. Their value isn't in their truth, it's in their effectiveness.
So just by changing that one question, we get a completely new and honestly a much more solid way to measure what success even means in science. The goal isn't some abstract truth. The goal is effectiveness at solving problems.
And look, here it is straight from Laudon himself. The real test of a theory's merit isn't all this abstract philosophical stuff. It's about performance. Does it work? Does it solve problems that we actually care about?
So the takeaway here is really important. Science stops being this grand quest for some single, final, capital T truth. Instead, it becomes this dynamic, ongoing process of just finding and building the most powerful problem-solving tools we can get our hands on at any given moment.
Okay, now hold on, because this is where the idea gets truly revolutionary. This whole problem-solving view, it doesn't just change how we define a good theory. It completely flips our entire understanding of progress and rationality upside down.
Okay, check out this flip. The old way of thinking was you have a bunch of scientists making rational choices, and the result of all those choices is progress. Laudon just flips that script completely. He says, look, we can see progress. We can look back and see that one theory solved way more problems than its competitor. That progress is the real thing we can observe. And that visible progress is what we should use to define what it means to be rational.
So, in this new system, what does a rational choice even look like? It's super simple, actually. It's just picking the theory or the research path that solves the most problems, the one that's making the most progress. Progress defines what's rational, not the other way around. It's a total reversal.
So this all brings us to the big final takeaway. Scientific progress isn't this nice, neat, steady march towards some single, fixed truth. It's something much more dynamic, much more adaptive. It's the process of solving more and more complex problems, of constantly building a better and better toolbox for making sense of the world.
You see how this just completely reframes the whole enterprise of science? It manages to save the idea that science is rational, but it does it by making it so much more grounded and practical. And it leaves us with a really powerful question to think about. I mean, if scientific progress is really all about solving the most significant problems, what are they? What are the most important problems our best minds should be tackling today?